We are going to the next typical questions of your IB board paper number 1, right? Lattice enthalpy, right? What do you mean by lattice enthalpy? That's a very important question you have to master. So this is a common question of the boards, right? Lattice enthalpy, right? We have to understand that what do you mean by lattice enthalpy? Lattice enthalpy is an enthalpy change when one mole of the ionic solid is broken down into its gaseous ions, right? Right, this, right? Gaseous ions. So this is the lattice enthalpy, right? Lattice enthalpy is always endothermic, right? Why it is endothermic? Because it needs energy to pull out this ions, right? And these ions are not in a isolated NaCl, right? Rather than that, it stays in a gigantic lattice structure, something like this, right? We learned in the GCs also, it stays something like this. See, guys, I'm showing you this. This one here. See here. It stays in a gigantic lattice structure, right? When millions of Na pluses is surrounded by millions of Cl minuses, right? Fine. So if you see the lattice enthalpy of any ionic compound is very huge. Sodium chloride is approximately how much? Approximately plus 771, right? Kilojoules per mole. Huge, right? Isn't it? Now lattice enthalpy is what? Let's go and see over here. Wait. Here you go, right? So lattice enthalpy is the enthalpy change when one mole of the ionic compound is broken down into gaseous, and the gaseous ions are very important, right? Remember one thing, in your IBDP, right? You will be having lots of questions of the definition equation, right? Fine. Now, to understand that, what does lattice enthalpy depends upon, right? Lattice enthalpy depends upon two things, right? It will be depending upon the charge, right? It's very simple. It depends upon the charge. So suppose you are having what? See, I'm taking NaCl, right? I'm taking MgCl2, right? Fine. See, I'm making the Cl minus controlled variable. See, I'm doubling the charge, right? If you double it, if you double the charge, right, what happens? The lattice enthalpy will be increasing, right? Isn't it? That's very easy, right? That's very. See the data over here. This portion we are having over here. See in this data, if you see, here you go, right? Here you go. So here we are seeing what? We are doubling the charge. See, Na plus Cl minus 1, Mg2 plus Cl minus 1, right? See, we are doubling it, the charge. So lattice enthalpy will be directly proportional to the charge of the ion, right? Fine. Now, as we go down the group, what happens? Suppose I'm going from lithium, sodium, potassium, right? Rubidium, right? Cesium. What happens when you go down the group? The size of the atom increases, right? Isn't it? Isn't it? Size of the ion increases. So the same positive charge is in the smaller radius. When you reach rubidium, the same unit positive charge in a larger radius. So the charge density is more in lithium. The charge density, you have to talk about the charge density. This charge density, you have to take on the ligands also, right? That in the transition metals, right? That the transition metals have got a high charge density. A smaller size will be ensuring what? A higher charge density, right? So if I'm taking lithium, if I'm taking sodium chloride, right? See, sodium chloride, and I'm taking cesium chloride, right? When you go down the group, what happens? The charge density decreases because the size of the atom increases. Can you see the size of the ion increases, right? Hence, if I'm taking lithium chloride and cesium chloride, what happens? The lower charge density is in cesium, so it's easier to take out the electron, right? So it's easier to break down the ionic compound, right? So we can tell what the second constituent of this enthalpy, lattice enthalpy. The lattice enthalpy is directly proportional to the charge of the ion. Second, lattice enthalpy will be inversely proportional, right? Inversely proportional to the size of the ion, right? Isn't it? Size of the ion. Now let's with this armed with this theory, let's go to the question. In the question, you see what? See, if I'm taking, if I you have to go for a whole elimination round away, right? Now, if you see, suppose I'm taking this, we are having we are having we are having we are having MgBr2, right? We are having MgBr2, right? We are having SRO, right? We are having RbBr, right? We are having NaBr, right? So we have to put the charges, see, +1 -1, right? We're having +2 -2. We're having +2 -2, right? We're having +1 -1, right? So we delete this part, right? We delete this part, right? Right. Highest. I'm just changing the question. Highest, right? Suppose I'm taking highest. So highest is what? You have to cancel out these two for the highest, not the smallest. See, when you walk around the multiple choice question, do the opposite also. Smallest, I'm going the highest. So these two will be the options which are there, right? Now, if you see, when we go down the group, what happens? The size of the ion increases. So magnesium is higher, right? Higher up in the reactivity series. If you see that magnesium, so this will be the answer, right? Because magnesium is smaller radius, high charge density. Now come to the part smallest lattice enthalpy. So smallest lattice enthalpy will be eliminating these options. Plus 2, minus 2 will be having highest. Now it also eliminates this. Can you see this? The combination, can you see? So this will be the lowest. Minus plus 1 minus 1. It should be lower than plus 1 minus 2, isn't it? Or it can be plus 2 minus 1, and this will be lower than what? Plus 2 minus 2, right? Isn't it? So plus 2 minus 2 combination will be highest, and plus 1 minus 1 will be lowest, right? So that we solve this lattice enthalpy, right? Isn't it? This question. Thank you so much. Thank you so much, guys.